Okay, so here we go with sections 7.5 and 7.6. These are the sections where we finally get the rest of our trig formulas. So the first thing I want to show you is this handout. It's in the very back of your book, and if you go to the back pages of the book, I'll also give it to you in class. But these are basically all of our formulas. Right here below the pink line, those are the ones we're going to use in chapter 8. So if we look, we already know these. We already know the even and odd functions. We've been playing with those. We memorized the sine squared plus cosine squared equals 1, which is off the Pythagorean theorem, so we knew that one. And I showed you how you can derive those two from the sine squared plus cosine squared equals 1 by either dividing by sine squared theta or by dividing by cosine squared theta, whichever one you needed. So we've got all that done. The big thing that you need to memorize for me are these. And yes, they can be derived, but I think because of the pattern that most of these have, the way they're in the pairs, I think it's easier if you just go ahead and memorize those. So memorize the sum and difference formulas. These I will always give you. The product to sum and the sum to product, I will always give you those. We don't do a lot with them. I'd give it to you, you would be able to plug it in. So the big thing that you have to decide is, what do you want to do about the half angle formulas and the double angle formulas? Do you want to just flat out try to memorize them, or do you want to derive them? Personally, I'm thinking deriving them is smarter, because then when you go into the test, you'll write down this one, the sine squared plus cosine squared equals 1, and then you really quickly get the 2 right after it. You'll write down those 6 in the pairs, and then you can get the double angle and the half angle formulas really quickly from the sum and difference formulas. Okay. So let me show you that in case that's the way you want to do it. The half angle formulas and the double angle formulas are not quite as easy to just flat out memorize, so deriving them is actually pretty smart. So keep the sum and difference formulas in front of you. Write them down, and then I'm going to flip over here to my very last page because I need some space. All right, so let's do the double angle formulas first, okay? So we had a formula on our sheet that said that the sine of alpha plus beta is the sine of alpha plus the cosine of, times the cosine of beta. Let me back that up. Times the cosine of beta plus the cosine of alpha times the sine of beta. And then I'm just reading that off that sheet. That's one of the ones we're going to memorize. Okay, so to get to a double angle formula, all right, so suppose we want to know what the sine of 2 theta is. This is one of the ones that they write as a double angle formula. Okay, well, that's the same thing as the sine of theta plus theta, right? The sine of 2 theta is the same thing as the sine of theta plus theta. So if I start plugging this into my formula, I get the sine of theta cosine theta plus cosine theta sine theta. Now, these are connected by multiplication here, and they're connected by multiplication here, and we know that's commutative, so essentially that's the same thing. I have one sine theta cosine theta, and I have another sine theta cosine theta, so I have 2 sine thetas cosine thetas. And if you look, that's your first double angle formula with sine. Right, I'm going to turn the page for cosine because I want lots of space. All right, so for cosine, again, let's take the, let me go back to my pink. So take the sum formula, take the cosine of alpha plus beta. So the formula says that's cosine alpha cosine beta minus sine alpha sine beta. All right, so we want to do, change colors again. So suppose we want to do cosine of 2 theta. Okay, so cosine of 2 theta. Again, that's the cosine of theta plus theta. So if we use our formula, we get cosine theta minus sine theta sine theta. Okay, well, cosine theta times cosine theta, that's just cosine squared, right? Minus sine theta times sine theta is sine squared theta. So that's your two, that's one of the formulas. They give you 3 different formulas for cosine of 2 theta. So that's the first one. Okay. Now, to get the others, what you can do is, again, I'm going to change colors. Right? Do you remember we had good old sine squared theta plus cosine squared theta equals 1 as one of our Pythagorean identities? So suppose we're doing a double angle formula and we're working it out, and we've got down to this cosine squared theta minus sine squared theta, and we don't want to use either both. We don't want to use both of them. We either want to use just the cosine squared or we want to use just the sine squared. So what we can do is we can take this good old Pythagorean identity and solve it for either sine squared or cosine squared, and then we can substitute. So, all right, so I've got right this minute, I've got cosine of 2 theta, because that's from here, equal to cosine squared theta minus sine squared theta. And suppose I just want that thing in terms of cosine. I can go right here where it says sine squared of theta, and I can use this one to substitute in. So what would I have? So it would be 1 minus cosine squared. And if I clean that up, that's cosine squared theta minus 1 plus cosine squared theta. So I actually have 2 cosine squared theta minus 1. So that's one of the other double cosine of 2 theta formulas. One of the other double angle formulas. Okay, so I've got it here in terms of both of them. Now I've just figured out how to do it in terms of just the cosine. I could also do it just in terms of the sine. Same idea. I've got cosine of 2 theta equal to cosine squared plus sine squared. Sorry, that's getting tight there. Okay, and if I want it just in terms of sine, let's substitute for cosine squared. If I substitute for cosine squared, I would have 1 minus sine squared theta, and then plus my sine squared theta that's trying to go off the screen. Oh, was that a plus or a minus right there? Oh, look how I miscopied that. Oh, sorry. Let me fix that. Where's my eraser? Yep, there it is. Right there. Sorry, I miscopied it. Back again. All right, see, I miscopied the minus sign. It's cosine theta. I was worried about trying to fit it in here. All right, so I've substituted for cosine squared theta. I substituted 1 minus sine squared theta, and then that should be minus sine squared theta. And now if I combine like terms, I get 1 minus sine squared is minus 2 sine squared. And that's the other double angle formula for cosine. So we had the one for the double angle formula of sine. We really quickly find this one for the double angle for cosine, and just like we did with the Pythagorean identity, if we want to switch it in terms of some other functions, we can make a substitution and come up with these other two, this one and this one, to go with this one. Okay. All right, we need the double angle formula for tangent. So again, I think I was doing that in pink, wasn't I? All right, so from your sum formula, you had that the tangent of alpha plus beta, it was it was tangent alpha plus tangent beta over 1 minus tangent alpha, tangent beta. Okay, so if we want to do a double angle formula, that means I want to do the tangent of 2 theta. So that's the tangent of theta plus theta. And if I substitute, I get tangent theta plus tangent theta over 1 minus tangent theta, tangent theta. So on the top, I have 1 tangent theta plus another tangent theta. That's 2 tangent thetas. And on the bottom, I have 1 minus tangent theta times tangent theta. That's tangent squared theta. Okay. So that's the double angle formula for tangent. Okay. All right. So those aren't too bad. Suppose we want to get those half angle formulas, and you're going to have to pay attention real carefully here with the notation. To get to the double angle, to get to the half angle formulas, what we want to use is we want to go back over here, and we're going to actually use this green, this one, and this purple one. We need those two cosine double angle formulas to make the half angle formulas. Okay, so back over here again. So what I'm going to use is I'm going to use the one that was cosine of 2 theta is 2 cosine squared theta minus 1. And then I also want to use the one that's cosine of 2 theta is 1 minus 2 sine squared theta. So those are the other ones we just derived. Okay, so suppose I wanted to rearrange this. So to get at the ones that are the half angle formulas, notice how they've got the square roots in them. So the idea is basically I want to isolate, in this first one, I want to isolate the cosine squared theta so that I can take square root of both sides. And then I'll do the same thing on the other, I'll isolate the sine squared. Okay, so we know that the half angle formulas have the square roots in them. So I'm going to add 1 to both sides. And if I add 1 to both sides, I get, cosine of 2 theta plus 1 equals 2 cosine squared theta. And then I want the cosine squared theta by itself, so I'm going to divide by 2. Okay. So that and that will reduce. So I'm going to flip it, so I have my cosine squared on this side. So cosine squared theta is the cosine of 2 theta plus 1 over 2. And then if I want to, I can take the square root of both sides. And I just have to remember, so now it won't be. So now it'll be the cosine of theta is plus or minus the square root of cosine of 2 theta plus 1. And the plus 1 is not a part of the argument of the cosine over 2. If you notice how the formula sheet writes it, it actually writes 1 plus cosine of 2 theta, but mine just happened to come out this way, so it's not really a big deal. It's still exactly the same thing as what you see on the sheet. Notice, though, that because they want to call these the half angle formulas, the way it's written on the formula sheet, right here it has a theta over 2, and right here it has a theta. And don't let that bug you too much, because realize it's whatever is over here, whatever this is, it's doubled here. So if this is 5, this is going to be 10. So I could write 5 here and say this is 2 times 5 there. I could also say this is 10 over here, and this is 10 over 2. over here. So it's just, you can change the notation. It just depends on what we're defining, you know, what we're using for that angle. It's just like how we used alpha and beta in some of the other formulas. It makes no difference. It's just whatever symbol we've picked. So we've used theta in the double angle formulas. So when I got ready to go through here and do my half angle formulas, this is the way it ends up. But in the book, to make it look like, okay, remember, this is a half angle formula, what they do is they substitute, just kind of like I was playing with the 5 and the 10 a minute ago. They say, well, the cosine of whatever is equal to plus or minus the square root of the cosine of double that. Okay. Think about it as being two different cosine. I mean, two different thetas. Like, think about this as being theta sub 1 or something like that. And now this is theta sub 2. You know, so it's using the same symbol, but it's not. It's switching. It's not really meaning the same angle. Okay. So either one works. Right. Oh, I need to do the other one. Let's see. Change back to blue over here. All right, so to get the half angle formula in terms of sine, we need to solve the one on the right for sine squared, so just like we did a minute ago. Let's subtract 1 from both sides. Get cosine of 2 theta minus 1 equals negative 2 sine squared theta. Oh, and then I got that whole negative 2 thing. All right, so I'm going to divide by negative 2. I'm going to be real careful with my signs here. So the cosine's going to become negative, and the sine and the 1 is going to become positive if I want to get that negative out of the bottom. Do you see that this is that on the left, this is the same thing as 1 minus cosine of 2 theta over 2? And then on the right, we'd have sine squared theta. Okay, I'm going to do the same thing. I'm going to take the square root of both sides. I am going to reverse it. So that it'll match the formula sheet. I take the square root of both sides. Oops. I get sine of theta equals plus or minus the square root of 1 minus cosine of 2 theta over 2. And again, if I want to, I see that whatever this angle is here, it's doubled over in the formula. I mean, I could say that it's the sine of alpha over 2 and then cosine of alpha in the formula. The main thing is whatever I say here, I have to double it here. So don't get all hung up on what your symbol is, all right? So this is going to be to make it match the formula in the book. And let me change colors so you won't think I've just miraculously changed that. All right, so I'm just going to substitute where it says theta and 2 theta. Instead of writing it that way, I'm going to say it's sine of theta over 2. 1 minus cosine theta over 2. And you might have to think about that. Oh, shoot, that's supposed to be, yeah, that's right. All right, so you think about that to make sure you kind of understand how I'm saying that these are equal. And again, the way I'm saying that is because the theta is representing something else. The theta is representing two different angles the way I've written it. But this is the way you can derive it without having to memorize the formula. And I think that we've got one more left, right? The tangent. All right, so let's see. So if we want the tangent squared theta, well, we know that's cosine squared over sine squared, right? So pick up those little formulas from the last page. We said cosine squared was what? 1 plus cosine 2 theta over 2. And we said that the sine squared was 1 minus cosine of 2 theta over 2. The 2's will reduce. And so I've got 1 plus cosine of 2 theta over 1 minus cosine of 2 theta, and that was equal to the tangent squared of theta. So same deal. I want to know what the tangent is, so I'm going to take the square root of both sides. So I'm going to say the tangent of theta is equal to plus or minus the square root of 1 minus the cosine of double that angle over 1, one's plus, this one's minus, 1 minus the cosine of double that angle. And again, to make it match the formula sheet, you can call the first one, you can say the first angle is tangent of theta over 2, and then that lets you go in the square root. Oops, that's plus or minus there. 1 plus cosine theta over 1 minus cosine theta. Okay, and now for all of the half angle formulas, whether you pick the plus or minus is going to depend on where this angle is. Okay, so just like when we were doing our inverse functions, everything that we've been doing, we've stopped to think about, now where is this angle? Where's the answer going to be? So we look at where this angle is, and that tells us whether we're going to get a positive or negative answer. Same thing if I go back here, when I get ready to try to pick for the cosine and the sine, I look at where the angle is, and that tells me whether I pick positive or negative. Okay, so all that to say those are the formulas we have to memorize. I'm going back here. All right, so how does this stuff work? Is this my first page? I think it is. All right, so suppose I want to use these formulas, right? And suppose I give you the problem, the sine of 5 pi over 12. And it's not something that you recognize immediately right off of the unit circle. And the whole idea is you're supposed to be able to do these without a calculator, so you've got to be able to rewrite it into something that you know. So start thinking about ways you could break 5 pi over 12 down. So think of the 5 over 12. How many ways can you rewrite it? You could say it's 1 over 12 plus 4 over 12. Well, 1 over 12 isn't on the unit circle. That's not going to help us much. What about if I said it was, can I say it's 3 over 12 plus 2 over 12? That might work. So look what happens. You're looking at this, you're trying to break it down. There's lots of different ways you can do it. But what you're trying to do is to break it into two angles that you can add together to get you the 5 pi over 12, but hopefully the two angles are going to be on your unit circle. So what if I pick 3 pi over 12 and 2 pi over 12? And there's others you could have picked, but suppose that's what I picked. So what that gets me is if I reduce my fractions so that I'll recognize them, 3 over 12 is what, pi over 4? And this one would be pi over 6. And I know what those are. I can read them right off of my unit circle. Okay, so now I need my formula. And my formula, so that's one of the ones you're going to memorize. Okay, it's the one where we say sine of the first thing times cosine of the second thing plus cosine of the first thing times sine of the second thing. Then you just read it right off your unit circle and clean it up. All right, so sine of pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is root 2 over 2. And sine of pi over 6 is 1/2. So now if you multiply these things together, you get what? Pi over 6. Or pi, bleh, where's a pi? You get square root of 6 over 4 plus square root of 2 over 4, which you can leave it like that. You can also say it's root 6 plus root 2 over 4. That's your answer. Okay. All right, so now look at that next one. The tangent of 40 minus the tangent of 10 over 1 plus the tangent of 40 plus the tangent of 10. Now, again, I don't recognize exactly what those are, right? But the way that's written, it looks suspiciously like those sum and difference formulas. So which one is it? Is it the sum formula for tangent, or is it the difference formula for tangent? So if you remember, you're looking at that numerator. This is actually the difference formula for tangent. So this is the formula that you get for tangent of 40 degrees minus 10 degrees. And did you notice how it switches back and forth in this section from degrees to radians? Pay attention to that, okay? So again, all I did was look at this problem. All right, which one of my formulas does it match? Okay, it matches the tangent difference formula. So that means what I'm actually doing is I'm doing the tangent of 40 minus 10. Well, that's the same thing as the tangent of 30 degrees. And I know what that is. I can read it off my unit circle. What do you get? Root 3 over 3? That's your answer. All right, let's see. What do we have next? That one. All right, again, you're supposed to be doing this by hand. You're looking at this. Pi over 18, 5 pi over 18 is nothing we recognize off of the unit circle. But if you look at the pattern, sine of something times cosine of something plus cosine of the first thing times sine of the second thing, that's again from your sum and difference formula. Okay. It's from your sum formula for sine. So what you can do is you can say, oh yeah, that's coming from that formula, this one. Now, hopefully, it's going to just kind of collapse now. So 1 over 18 plus 5 over 18 is 6 pi over 18, which conveniently reduces to pi over 3. What's the sine of pi over 3? Read it off your unit circle, root 3 over 2. Okay. Now, this is the one that we were fighting, we were fighting a few minutes ago with the notation we wanted to use for the half angle formulas. All right, so when I look at this thing, 195 is not something I recognize off the unit circle, right? I mean, I can figure out where it is. I mean, if I think about, my quadrants, if this is 180, I mean, I know that 195's got to be there in the third quadrant. I mean, I know where it is, but it's not one of my set values that I memorize. I can't right off the top of my head think of a really easy way to break that up using the sum and difference formulas. So what about, what's 195 half of? It's 390, right? So, right, this is where I'm playing with notation. Do you buy that 195 is half of 390? Okay. Now, why do I care? 390 I can read off my unit circle because that's one revolution, and then how much more? 30. Okay, so that would be really convenient. All right, so now I've got to use my formula, okay, and that's the one with the square root. So, got too many colors here. All right, so plus or minus the square root. All right, what is it? It's 1 minus cosine of 390, and I should be putting my degree symbol, sorry, over 2. Now, go ahead and decide, is it positive or negative? Okay. So go back here, say to yourself, I'm finding the sine of 195 degrees, which is 390 over 2. That is in the third quadrant. In the third quadrant, a sine value must be negative. So I can go right back in here and immediately know that that answer better be negative. Okay. So now I just need to finish it. So okay with the fact that the cosine of 390 is going to give you exactly the same answer as the cosine of 30 degrees? Again, that's my little pink thing where I was drawing over here, is where I go around 360 and 30 more gets me to the 390. All right, what's the cosine of 30 degrees? It's root 3 over 2. Over 2. All right, so now this is where it gets really fun because you can't leave your answer like that. It's just, that's too many complex fractions. So what you're going to want to do is, well, you can think about it as multiplying top and bottom by 1/2 over 1/2, if that works for you. Lots of different ways to think about it. I'm going to go with that one for the moment. All right, so this is the same thing as the negative square root of 1/2, because 1 times 1/2 is 1/2, minus root 3 over 2 times 1/2 is root 3 over 4. And then I get rid of my denominator because 2 times 1/2 is 1, so this at least gets it to here. All right, now what? Can I pull that together into one fraction? What about, can I say this is, multiply this by 2 over 2? I feel like I'm going in circles, but what I'm trying to do is I'm trying to make it look better. So I'm going to say this is the negative square root of, can I say that's 2 minus the root of 3 over 4? And the reason I wanted to do that, because I was going to try to take the square root of the top and the bottom. And so that gives me the negative square root of 2 minus the root of 3 over the square root of 4 is 2. So I don't know if we think that's a whole lot better, but that's about as far as we can take it. We're not going to get it much further than that. I do know that you probably cannot stop with it here. Computer's probably going to yell at you, and it's really not the best form, so you want to take it as far as you can. I would probably try to get it to here. All right, what else have I got? Okay. So given the stated conditions, find the value of each expression. Okay. So notice I'm going to do these sum and difference formulas, and if you think about it, all of your sum and difference formulas require that you can do the sine of alpha, the cosine of alpha, the sine of beta, the cosine of beta. And if you look at what they give you, all right, so we've got this piece, so we know what the cosine of alpha is, and we're told that alpha is in the first quadrant. So we can figure out what the sine of alpha is, can't we? We can say, and this is not me even touching the A, B, and C yet. This is just me trying to figure out what the sine of alpha is going to be. I like my good old Pythagorean identities. Alpha. So cosine alpha, cosine squared plus sine squared. I just keep wanting to write theta equals 1. So I can substitute root 5 over 5 into my good old Pythagorean identity, and I can solve for the sine of alpha. So what is that? 5 over 25 plus sine squared alpha equals 1. Subtract the 5 over 25, and we get what? So 25. What did I drop? Okay, nothing. Let's see. So 25 over 25 minus 5 over 25 is going to give me what? 20 over 25, which I probably need to go ahead and reduce that to 4 over 5. And then I'm going to take the square root of both sides. And I'm going to get that the sine of alpha is what? The square root of 4/5. Is it going to be positive or negative? If alpha is in the first quadrant, this is going to be positive. And now I do need to make this look prettier. That's the 2 over root of 5. And if I rationalize, I get 2 root 5 over 5 for alpha. All right, so I'm going to come up here and write this because I'm going to have to erase some stuff because I'm going to run out of space. So I've got that the sine of alpha is 2 root 5 over 5. Okay, so now, let's see. I got the sine of beta. It's negative 4/5. And where is this? It's quadrant 4, right? All right, so this one's quadrant 4. So I need to pay attention to my signs. Alpha was cool. It was in the first quadrant, so the cosine and the sine give me positive answers. Sine of beta, beta's in the fourth quadrant, so that's negative. Cosine's going to be positive. All right, so I need to do the same thing. Again, I haven't even started working the problem yet. I'm just trying to get all my pieces. I need to find what the cosine of beta is, so I'm going back again to cosine squared plus sine squared equals 1. And I'm going to substitute for sine squared, negative 4/5 quantity squared. So cosine squared beta plus 16/25 equals 1. Cosine squared beta equals 9/25. Square root of both sides. 3 over 5, and again we said it's positive because it's in quadrant 4 and cosine's positive there. So I'm going to come up here and I'm going to write this because I'm going to have to erase. So cosine of beta is 3/5. Okay, so now I have all of my pieces. I've got sine of alpha, cosine of alpha, sine of beta, cosine of beta, and I'm going to erase all of this because I need some space. Where did it go? There we go. Erase. There we go. All right. So let's do A. So it's just number crunching. I might not do all of these. I'm just going to do maybe a couple of them just to show you. Let's do A. Let's do sine of alpha plus beta. So you pull up your formula. Your formula is what? It's the sine of alpha cosine beta plus cosine alpha sine beta. So sine of alpha, we already found that. We found that it was 2 root 5 over 5. Cosine of beta, we found that's 3 over 5. Cosine of alpha was root 5 over 5. And sine of beta was negative 4 over 5. Okay. Cool thing here is the denominator of both the fractions is going to be 25, so at least we're going to be able to combine this fairly easily. So 2 root 5 times 3 is 6 roots of 5. Then root 5 times minus 4 is minus 4 roots of 5, all over the common denominator of 25. Okay, well, if I have 6 roots of 5 minus 4 roots of 5, that's 2 roots of 5 over 25. That feel okay? Why don't we do the tangent one? Let's do that one. Let's skip and do D. All right, let's see. Different color. All right, so let's do the tangent of alpha minus beta. So write your formula. This one is the tangent of alpha, minus the tangent of beta over 1 plus tangent alpha tangent beta. Okay, so do we have our tangent values? What's the tangent of alpha? Here we go, changing colors again. Let's go over here on the side. So tangent of alpha is what? Sine over cosine. So 2 root 5 over 5 over root 5 over 5. That's 2, isn't it? So the tangent of alpha is 2. And tangent of beta, again, we're doing sine over cosine. So sine of beta is negative 4/5 over cosine beta is 3/5. That's negative 4/3. Okay, so now I got to substitute all that in, and I gave myself no space to do it. Let's see. So coming down here, tangent alpha, is 2 minus negative 4/3 over 1 plus 2 times negative 4/3. Yikes. Okay. All right, so this is the same as a plus. Couple of different ways you can do this. I'm going to go by multiplying top and bottom by 3. I'm going to multiply every single piece of this by 3, and that's going to give me 6 plus 4 over 3 plus minus 8. Other ways to do it, that's just the way I was thinking that I could get rid of everything really quick. Multiply every single thing by 3. That's 10 over negative 5, which is negative 2. That's the answer to D. Okay. Got anything else? Oh, 2 more. Okay. This one. Again, it's the same idea. So let's pick a couple of them. Notice how they give us the cosine of theta and they give us where it is. So from pi over 2 to pi, that's quadrant 2. And so I need to find my sine value, just like I was doing on the other problem. That's the cosine squared theta plus sine squared theta. That's just the way I always do it. Oops, sorry. So negative root 6 over 3 quantity squared plus sine squared theta equals 1. Gotta get away from that page turn. So what is that? 6 over 9 plus sine squared theta equals 1. Subtract the 6/9. Well, 6/9 is the same thing as what? 2/3. So subtract that to the other side. We get sine squared theta equals 1/3. Take the square root of both sides. Sine of theta. That's the square root of 1/3. Are we to the point we know that's the root 3 over 3? And if we're in quadrant 2, is it positive or negative? It's positive. Okay. All right, so I got my cosine value, I got my sine value. Now I'm doing my formulas. It's really just, again, the same number crunching I did on the other examples. Let me just tell you what the answers are. This one should be negative 2 root 2 over 3. This one should be 1/3. This one is the square root of 3 plus the root of 6 over 6. And D is the square root of 3 minus the root of 6 over 6. I'm worried that my video is getting too long. That's why I'm not going through that. Let me see what else I've got for you. that one falls right out. So I'm going to skip that one. All right, I want to do one of these. And then I think I'm going to have to stop because I think my video's got too long. Okay, so they like to give you these pictures. Very similar to the conditions on the other one we just did. They're giving you pieces of it. You got to stop and find the other pieces you need before you can actually go about finding these function values. All right, so notice on this first one, they give you a circle, x squared plus y squared equals 5. So we know that means that the radius is the square root of 5. And they've given us this point over here, and they've called it A2. And they don't want to tell us what A is. They're going to make us go over on the side and figure that out. Well, again, that's your good old Pythagorean theorem. You know, x squared plus y squared equals r squared. So I can really quickly find what A is. If I've got A for the x, and I've got 2 for the y, 2 squared is 4, equal to root 5 squared is 5. Okay, so subtract 4 from both sides. A squared equals 1. So A equals plus or minus the square root, or A equals plus or minus 1 if you take square root of both sides. And if we're in quadrant 2, A has to be negative 1. Okay, so this point is actually negative 1, 2. Okay. Now what that gets us is now for theta. Okay, so for this first thing over here, I can stop, because I know for all my formulas I've got to have sine and cosine values, right? So I can stop right this minute and I can say that the sine of theta, okay, so sine of theta is what? 2 over root of 5, y over r, which that's the same thing as 2 root 5 over 5. And I can go ahead and say that the cosine, that the cosine of theta is x over r, so negative 1 over the root of 5, which again is better written as negative root 5 over 5. So that's basically the pieces I need from the first circle that have anything to do with theta. Okay. You could do exactly the same thing with the second circle. It's going to fall out a little bit quicker because the radius on the second circle is 1. But let me play with just these two for a second. Because H, the last one has to do with the second circle, and they just put these together to make it look all complicated. It really has nothing to do with the first problem. It has nothing to do with the circle that has theta. So let's just do those first two. I'm going to have to erase. You've got those written down. I just need some space. Okay. So g of 2 theta. Okay, and up here at the top, notice there's this little box up here that says g is actually the cosine function. So what this first one is it wants me to do the cosine of 2 theta. Okay, so that's one of the formulas. We'll have written that down to start with. That's the one that had 3 different ones you could pick, but the first one that we got was the cosine squared theta minus sine squared theta, and then we derived the other two, so I'm going to go with that one. All right, so we just figured out what cosine of theta was, and you said that that was negative root 5 over 5, quantity squared, minus, and we said the sine was 2 root 5 over 5, quantity squared. So we clean that up. So that's going to be positive 5 over 25, which is going to reduce to 1/5. We'll get to that in a minute. And then this other one is going to be 4 times 5 on top over 25 on bottom. Okay, so that's the same thing as 1/5 minus 4/5, which is minus 3/5. So g of 2 theta is the same thing as the cosine of 2 theta, which is negative 3/5. Right, and let's do that half angle formula. All right. Okay, so f was defined up at the top to be the sine function. So this one is actually asking us to find the sine of theta over 2. Okay, so what's your formula? What quadrant are we in? We're in the second quadrant. Sine value is going to be positive. Well, okay, let's see. Well, now theta's in the second quadrant. Theta over 2, it might be in the first quadrant, but it sine's positive in the first quadrant too, so we're like, ha, we got that. So this is going to be the positive square root of 1 minus cosine theta over 2, and I'm just reading it off my charts because I've already written those down. All right, so this is the square root of 1 minus the cosine of theta was negative root 5 over 5 over 2. Oh boy, so we got to clean that up. Let's multiply through by 1/2. That's what we did on the other one. Let's try it again here. Let's multiply on top and bottom by 1/2. So that's the big square root of 1/2 plus root 5 over 10 over 1. So I don't have to write the over 1. And then what we did on the other one, on the other problem, is we then added those two baby fractions together, multiply top and bottom by 5 to get a common denominator. And that's the square root of 5 plus root of 5 over 10. All right, this video is getting very long, and I'm sorry for that, but I do want to show you an equation. I've got 2 of them. Let's see if we can get through them. So you want to solve this on the interval from 0 to 2 pi, and this is what you're given. So one little trick that works well with these is if you will get one of the functions on one side and one on the other, you can square both sides. It's the idea that we used in 150 when we had like 2 different radicals in one equation and we were trying to get rid of the radicals. So what we could do here is we could subtract the cosecant over there with the root of 3. And what that's going to get me, I'm sorry, that's a theta, is the chance to square both sides. And the reason I'm thinking that might work is because I'm thinking of my Pythagorean identity that has cotangent squared in it. And I know it also has cosecant in it, so I'm like, that might work. All right, so what I want to do is I want to square the left, and I want to square the right. Left falls right out. That's just cotangent squared theta. I'm watching my notation. On the right, I got to be careful. I have to FOIL this. Okay, so I got to make sure I get all the pieces. So negative cosine squared times cosine squared is cosine squared theta. And I think I said that totally crazy. Negative cosecant squared. No, negative cosecant of theta times negative cosecant of theta is positive cosecant squared theta. Okay, then outer times outer minus cosecant theta times minus root 3 is positive root 3 cosecant theta. Inner times inner, same thing, positive root 3 cosecant theta. So middle term is plus 2 root 3 cosecant theta. And then last times last is negative root 3 times negative root 3 is positive 3. Yikes. Okay, so my whole point of that is, can I get it in terms of one function? I've got cosecant squared and cosecant on the right. I got cotangent squared on the left. Can I replace that? Remember your Pythagorean identity? Cotangent squared is equal to cosecant squared minus 1. And I don't really need the parentheses. I'm not sure why I put them in there. And it's equal to cosecant squared theta plus 2 root 3 cosecant theta plus 3. Okay, so what happens if I subtract cosecant squared theta from both sides? Don't they cancel out? So I've got minus 1 equals 2 roots of 3 cosecant theta plus 3. I want to get the cosecant theta by itself, so I could subtract 3 from both sides. And then I could divide by 2 root 3. So what is that? Negative 2 over root of 3 equals cosecant theta. Well, I don't know what that is right off the top of my head, but I do know that the cosecant's a reciprocal of the sine. So this tells me that the sine of theta is what? Negative root 3 over 2. And that I most certainly can do. Okay, where's the sine of theta? Negative root 3 over 2. Four pi over 3. That's a 3. And 5 pi over 3. Okay, now, and that's all squished down there on the bottom. The thing that you have to do whenever you decide you're going in and you're going to square both sides of the equation, you have to remember to check your answers. That's why I really wanted to show you this one. So we worked this all the way out. We got sine of theta is negative root 3 over 2. So on the unit circle, because we're going from 0 to 2 pi, that was in the directions, we know we've got two places. We've got the 4 pi over 3, and we got the 5 pi over 3. But you have to now take those answers and go back to your very original equation and plug it in and see if that statement is true. So if you take 4 pi over 3 and you go back up to the top and you say cotangent of 4 pi over 3 plus cosecant of 4 pi over 3, does that equal the negative square root of 3? And then you do the same thing with the 5 pi over 3. You do cotangent of 5 pi over 3 plus cosecant of 5 pi over 3. Is that equal to negative square root of 3? And what you're going to find is that the 4 pi over 3 doesn't work. Your only answer for this problem is the 5 pi over 3. So you do have to check your answers whenever you square both sides. Okay, I'm going to stop there because this is about an hour long. I hope this is helpful.